Welcome to our session on RISC-V learning. I'm super excited to be here with Stefan Wallentowitz, who has taken on many different leadership roles across the RISC-V community to help us infuse learning into the broader community. You know, learning captures a number of different areas, and we have three main themes that we are building and growing in RISC-V. First, we are connecting across universities. It is our aim to infuse RISC-V into the base curriculum in top technology universities around the world, and we are well on our way. We have more than 30 artifacts online already. In addition to academia, we are also embarking on a professional training curriculum that is hosted by professional training partners. Earlier in August, we launched the RISC-V Training Partner Program, and we're so excited to have 4 partners join us on that mission already. So take a look at that when you have a chance. We are also building out online curriculum, online learning for RISC-V engineers who are already working in the industry to go broad or deep on any number of subjects for RISC-V. So welcome, Stefan. Thank you for joining us. It's a pleasure to talk with you. Could you introduce yourself and the many ways that you're involved in RISC-V?
Hi, Calista. Thanks for the invitation. Yes. I'm historically a long-term contributor to open source projects, especially in the area of open source silicon. I started working on the OpenRISC project probably like 10 to 15 years ago. From that, grew more into the advocacy role in FOSSI Foundation, where many people probably know me from. And we observed like RISC-V from the beginning, like 2014, I think, was the first time we had some contact, as being like an important boost for the ecosystem of open source silicon. So it got pretty interesting to me, of course, to get involved in some way. And I tried to do in as many open source projects as possible, either as maintainer or as casual contributor. So many people probably have stumbled over me here and there. And since 1.5 years, I'm now a professor at Munich University of Applied Sciences, and of course try to bring in RISC-V in as many things as possible. And from there, it took me to this role in the special interest group on academia and education, which I now want to lead more into the direction of more open research, more open education materials, and try to evolve it as you have introduced.
And Stefan, you have also recently elevated your role even more in RISC-V International, and we recently welcomed you as one of our elected board members. So congratulations on rocking the vote and joining us at the leadership realm, and thank you for your leadership as our chair of our academic group. We really appreciate that.
Thank you very much.
Yeah, as a professor and leader in the open source community, what are some of the challenges faced by academia in bringing on RISC-V?
So I think there's two facets. The one is in research, generally, I think there's the challenge in comparability of research results and in common baselines. And I think there's a good opportunity there, but currently it's still a challenge, still also on the RISC-V side on incorporating it into research. On the teaching, I think the challenge currently is, especially if you're doing pretty much practically oriented education, as I do at the University of Applied Sciences, is that like because of the high popularity of the RISC-V ecosystem, it's a very dynamic ecosystem. So the stability and availability of projects is varying at the moment. I think this is one of the challenges that you have if you create a course nowadays. And finally, I think there's one thing that's also changing rapidly at the moment, which is the availability of hardware, in my opinion. I've seen many boards in the last year. I think there have been more boards this year already than there have been the 4 years before, right? I think this is a great thing, but it's still some of the challenges if you compare it to the availability of Raspberry Pi, for example.
Well, we are glad to have Raspberry Pi as one of our members, so as well as SparkFun and others who are really kind of helping us to build out the developer board opportunity. And in our new website, we have a number of boards available too. So you're right. You know, we're nowhere where we were, 5 years ago. We've continued to grow and continue to develop as a community. You know, what can we do in RISC-V to overcome specific challenges faced by professors, research, and students?
So I think one of the great things here is that in education, it probably has a long-term impact on the coursework and on the practical education of the next generation of electrical engineers and computer science students. I think RISC-V will certainly have a good impact on the quality and the relevance of research and student projects. And I see a good opportunity for the RISC-V ecosystem, especially out of this mix of proprietary and open platforms, right? There's clearly the relevance delivered on the one hand, and on the other hand, I think one of the things that I also want to drive as the chair of this academia and education committee is making available also like a high quality mix of educational material and practical educational labs, etc.
Yeah, I think once we bring the costs in check with sort of the applications that the academic community is seeking, then we're only limited by our imaginations.
Exactly.
RISC-V builds on the many ways that we've engaged academia from the beginning, from our roots at Berkeley to universities today around the world. And we're so proud to engage universities and students in our community memberships, highlighting important research and progress in our poster sessions, engaging together at events ranging from the Rios Lab grand opening in Shenzhen, China, to FOSSI events in Europe. How do you see us further kind of involving ourselves in the academic community?
I think the whole RISC-V movement, I would say, is it certainly has a good impact on the quality and the relevance of the research we see especially in areas like computer architecture, high performance computing, etc. And I see this is especially the route that RISC-V should go, is like nurturing this whole idea of relevant research on a common baseline with open materials. And as an open source enthusiast, I think it hopefully all further nurtures or increases the impact of open research and open education and the availability and usability in the end also of high quality projects that are out there. For example, if you have a look at ETH Zurich, what they did over the last years, like probably 10 years already, they've been working on open source silicon and making their projects available in a high quality, well maintained. I think that's a very good thing that the RISC-V community is bringing to the table beyond the RISC-V ISA itself.
That's incredible. So I mean, it's both a culture shift toward open source as much as it is tangible output. Show us your hardware. Like, we've got to do both. So
this has never been there before, right? So now you can just download stuff from the internet, and something that you don't have to explain to students because they already read it on Hacker News, right? They already know this stuff, and they are curious to learn more about it. And I think that's a great opportunity.
When I've been out in the community, the passion for RISC-V that I see ignited in the academic community has been profound. Yeah. And those are the seeds planted as we move forward for our industry. So can you show us some examples? You've been at this a little while now. Can you show us an example of what you've been working on?
Yeah, of course. Let me just show you two small examples of stuff how I use RISC-V in my education. For our course on computer organization, we have integrated a popular Venus simulator into a standalone Visual Studio Code extension. Students can develop and debug RISC-V code fully integrated into the IDE on any platform and without any extra tools. Visual elements like an LED matrix ease the learning experience. Students can step through code, change registers, and debug their code very easily. Later in their curriculum, in the course on computer architecture, students use very later models of actual processor cores, like the Western Digital Swerve EL2 in this example. With microarchitecture traces, they can observe the detailed pipeline timing and learn about microarchitectural details. To learn more about these and other tools and course materials, visit our website at risc5.cs.hm.edu or get in touch with me.
Thank you so much for the chat, Stefan. I feel much smarter already, and I'm so glad that we got to have this time together. Thank you so much. And thank you not just for today's chat, but for all you're doing for the RISC-V community. It's deeply appreciated.
Thank you very much. Thanks a lot for the great opportunity.